All right, if I may provide an official welcome, call us to order and provide an official welcome. I'm David Meyer. I'm the dean here, and I'm thrilled to welcome you to what is amazingly the 20th annual Tulane Summit on Environmental Law and Policy. That is a real landmark and something that we're very proud of. This is really such an exciting day to kick off this program and reflects a lot of work from students and faculty and staff who invest in this program. But it is first and foremost a student undertaking, which is a real remarkable achievement. And to assemble the kind of program that they have put together for you and to have brought in the figures from around the country and beyond to put together this quality of program is really a source of great pride for us at Tulane. So we thank you for coming here, for traveling from distant places, and for taking part in this program. And I just wanted to have the opportunity to thank and congratulate our student leaders as well, Emily and Allison, and all of the very large crew who are involved in all of the moving parts to this. This program, by the way, was recognized last year by the American Bar Association as the finest student program in the country in the field of environmental and energy law and policy. We're very proud of that, and it's reflected in the fact that we have, this year we're on track to set another record in terms of participation. We have just heard more than 525 registrants participating in this, so we're well on track to set a new record of participation, and of course fantastic programs for 2 days spanning a range of issues from bears and prairie dogs to ocean wind power and climate change and everything in between. So with that, I will welcome you again, and hope that you will have, sure that you will have really robust exchange over the next couple of days, and that many good things will come from this in terms of both the ideas exchanged here and the connections that you will make in the days ahead. So thank you so much.
Thank you.
Very well. Thank you. Well, I think we have constituted ourselves. I'd like to again extend my welcome to you. My name is Mark Davis, and I direct the Institute on Water Resources Law and Policy here at Tulane Law School. And I'm one of the faculty advisors to the students who put this extravaganza on. And yes, as Dean Meyer noted, this is the 20th annual Environmental Law and Policy Summit. But to be more accurate, since students are putting it on, it's never the same students each year. This is the 20th first annual Environmental Law Summit, because we have to make it up every year in some ways. So when you see the students, recognize that they have done an amazing job here. But it's a job that could not be done without the help of our sponsors. So on your program, I'd like you to see a list of our sponsors. And I won't read them all out to you right now. But if you get a chance to visit their booths, or if you run into their representatives, please extend a note of thanks, because I can tell you that once upon a time we had to charge admission to this conference. And people did come because it was worth coming. But one of the things we've been able to do because of sponsorship is make it open to the public free of charge. So say thanks to them if you get the chance. The thrust of this panel is climate change. More accurately, what we're doing about it, what we might do about it, and what you should be looking for if you're trying to track those conversations. It's been said that everybody says that, everybody talks about the weather and that nobody does anything about it. Well, everybody seems to talk about climate too, but increasingly there's a growing consensus that we not only have to talk about it, but we have to do things about it. And we have to do things not merely about the climate, but how we adapt to living with the changing climate. And that is what COP21 is about. Now, COP21, when I first heard it, I thought it was like a new Sylvester Stallone movie about a 21st century COP. It goes to the 22nd century and has to deal with, it's not quite that. Now, this is really COP21 is the 21st session of the conferees who are part of the United Nations Convention on Climate Change. So, if you're wondering where all these things fit, Kyoto, Rio, all these things, it's all part of a continuing conversation. It's additive. The next chapter will be in Paris, France in December 2015. And you get a preview of some of the things that may be coming up, some of the conversations that may be coming out of it, and some of the science that may be really the framework for discussing what we can do, what we might do, and where the burdens might fall. We're very fortunate to have a panel that's well equipped to discuss this for you. Our first panelist, and I'll tell you all three of them, and then I'll invite Monsieur Trumel up, will be the Honorable Gregor Trumel, who is the Consul General of France to Louisiana. He's based here in New Orleans. He's been here since last summer. And if those of you who had a chance to participate in the French-American climate talks here on campus last fall, got a preview of the kinds of discussions that are really behind this entire effort. We also have Dr. Tor Tornqvist. Tor is a professor of geology here at Tulane and the chair of our Department on Earth and Environmental Sciences. This is one of the areas that he has spent a great deal of time studying and really interacting with his colleagues about. And for those of you who think science is done in lab coats and isolated laboratories, he can dispel that notion. And our final speaker will be Dr. Will Burns, who's a scholar in residence at the School of International Service at American University and also the co-director of the Washington Climate Geoengineering Consortium. His take's going to be a little different. Now, I don't think that you're going to hear him say we ought not be doing things to reduce climate change. But the fact of the matter is, climate change is already happening. And anybody who lives here in South Louisiana knows this. Some of the things we're contending with about what makes our coast and communities viable are manifestations of a changing climate. And the plans that we're making here have to consider those things. Well, the adaptation aspect of climate change response has been sometimes lagging behind the other aspects of the conversation. And that's something that Dr. Burns has devoted a great deal of his attention to. So without any more, I'd like to introduce Monsieur Gregor Trumel to lead us off. Bienvenue.
Dear friends, it's my pleasure to be here. My name is Gregor Trumel. I've been in Louisiana for 6 months now. I'm the Consul General of France. Consul General of France, Consulate of France in Louisiana is the oldest French consulate in the United States. So it was created just after the very clever purchase by the United States of Louisiana in 1803. My background, I've studied political sciences, I would say some law, business, literature as well. And I was posted before in Copenhagen. So, but I arrived just after the battle, as we say in France. I arrived in 2010, so just after the COP15. So, Mr. President, Mr. Mark Davis, Dr. Mark Davis, thank you very much for inviting me. It's a great privilege to be here today with you. Because to prepare and to make this COP21 in Paris in December this year a success is a major priority of the French diplomacy for this year. So I'm very proud and very happy to be here and to have the opportunity to talk to you. The last time I came here was for the FACT conference, French-American Climate Talks, and it was a major, I would say, that's French arrogance, but it was, I think, a major success. So thank you very much. And I met Torbjorn at this time already. As you know, France will host the COP21 from November 30th to December 12th in Paris. You know, COP is the nickname for the Conference of the Parties to the United Nations Framework Convention on Climate Change. I think it's a good idea to call that COP. But it doesn't come from Copenhagen, you know, because the COP15 was in Copenhagen, so sometimes there's a confusion. And I would like the confusion with Copenhagen to stop, because, as you know, the COP15 was, I'm a diplomat, so I'll be very cautious, it was a disappointment, let's say. So we really want the COP21 in Paris to be a success. And it was a major, I would say, a strong decision from the French government to host the COP21 in Paris, because we know, we are very optimistic, of course, but we know it's going to be hard work to achieve an agreement. Let's say that. So, ladies and gentlemen, you know, we think we have time, and some people still think they have time, but it's a matter of urgency, as you know. The concentration of CO2 in the atmosphere broke a new record in 2013. Climate disruption is no longer a hypothesis, it's certainty. Global warming threatens peace and security, and as the President of France, François Hollande, said recently, climate disruption is behind more population displacements that are caused by wars now. So everything must be done to reduce global greenhouse gas emissions radically, so as to limit the global average temperature rise to below 2 Celsius degrees. Everyone knows the figures, and our duty is to put together a development model for the next 30 years, to let the peoples of the world have access to goods and, at the same time, to protect the planet. France is thus fully committed to making this COP21 conference a success. The aim is to establish a course of action and a legal framework to limit average global warming to less than 2 Celsius degrees, as I told you. And as President Obama said in the State of the Union address very recently, I love this quote, we don't need to be rocket scientists like Torbjorn or my colleagues here in the panel to see that climate change is happening and that we need to take action. That's from President Obama. So we must take action now to preserve both our quality of life and that of generations to come. This will not be easy, but there are many reasons to remain optimistic. The mobilization I see today in Tulane is one of them. This conference brings together a great number of high-level lawyers, scientists, NGOs, think tanks, and I guess some government officials and business who are all committed to finding solutions, as awareness is definitely rising. That's very good. So we need initiatives like this one to remind public officials how important the fight against climate disruption is for civil society, and to encourage them to maintain and take constructive actions. In short, we need to work together to confront reality before it's too late. Let me address the context and challenges in the background. Over the past few months, there have been many positive signs leading us to believe that the conference in Paris will be a success. First, the UN Climate Summit in New York in September, which succeeded in engaging world leaders in a global conversation about climate disruption and illustrated the involvement of non-state actors. Second, the European Union leaders agreed in October on a target to reduce their domestic greenhouse gas emission by 40% compared to 1990 by 2030. They also set a goal of at least 27% for renewable energy by 2030, and France pushed the EU to set these challenging objectives. When I was in Denmark, I remember very recently, 6 months ago, the percentage of renewable energy in the energy mix is already about 25%. You know, it's amazing. The agreement, the third good sign, between China and the US, announced in November, is historic. Since China committed for the first time to limit its greenhouse gas emissions, with emissions peaking around 2030, and the US committed to doubling the pace of its carbon pollution reduction by 2020. We saw this announcement as a possible turning point. 4. The objective we have of mobilizing $10 billion for the Green Climate Fund has been met. I would like to stress here that France will play a crucial role, as it will contribute up to $1 billion in a time of budget constraints, you know. 5, we are demonstrating through the work being done on hydrofluorocarbons, the HFCs, that if we are determined enough, we can take action concretely to reduce our emissions. It's been done already. So all the mobilization of all stakeholders and their collective efforts on climate action ensured the success of COP20 in Lima very recently, in December. And the negotiations have been difficult, of course. And this should not come as a surprise given what is at stake. But still, COP20 was a success for 3 reasons, or let's say 2 reasons. We kept all states on board, which is an issue. And the Lima conference on climate change laid the groundwork for Paris, so that's good. About the role of France, because one of my goals is to, of course, to enhance the role of diplomacy in this issue, and French diplomacy, of course. So France wants to act as the international community's honest broker in the future negotiations. Everyone needs to step up and engage in the negotiations, including the biggest greenhouse gas emitters, as well as civil society in every country. We are already witnessing the increasing involvement of the so-called big players, as we saw recently with China. Last month, President Obama also held interesting talks in India, for instance, and President Hollande is currently in the Philippines on climate issues. The example of India and Philippines, I think, is very, very interesting and illustrates the fact that we should not pit the fight against poverty, particularly energy poverty, against sustainable development. The fight against climate change should never be an obstacle to development. That's a very important point. The 2 challenges must be faced together. In a sense, a Paris Agreement should be also read as an agreement for growth. That's very important. In addition, climate, we think, should be among the issues discussed at the G7 and the G20. But this is not only about governments. We will only be able to succeed if all stakeholders are involved. That is why we decided to create in Paris, in the immediate surroundings of the negotiation center, an open and inclusive space dedicated to civil society. NGOs, academics, local governments and businesses will be welcome there to meet and discuss and network and raise some ideas and solutions. It's not just a diplomatic and an official meeting. France tries to show the path, you know, and to be an example, of course, as well, as a country. And we have been taking significant steps to fulfill our pledge to carry out an ecological transition by 2050. And in October, the French Congress, l'Assemblée nationale, passed a bill which will soon come before the French Senate and which sets ambitious goals regarding our use of energy and the protection of our environment. For instance, in terms of greenhouse gases, we aim in France to reduce our emissions by 40% by 2030 and by up to 75% by 2050. compared to 1990 levels. And next, we aim to reduce our fossil fuel consumption by 30% and increase the proportion of renewable energies to a third of our energy mix by 2030. And finally, we pledge to cut our energy consumption by half by 2050. French diplomacy actions in the US. Facts, we have made this great French-American climate talks program, and Tulane University proudly hosted one of the first FACT conference last November. It is a program that involves not just United States scientists and NGOs and officials, but Canada as well. It's North American. And we'll keep on organizing these events, FACT, this year. For instance, the next one is in Houston, so it's a big job in Houston, talking about climate. It's an issue. But, you know, awareness is rising, as I told you. What is important as well is, I think, the involvement of cities and metropolitan regions. Among the non-state actors, cities and metropolitan regions are major players in the efforts to address global warming. And metropolitan regions are often among the most vulnerable to the effects of climate change, and the cities are also very vital laboratories for testing and applying innovative technologies and policies to reduce greenhouse gas emission and promote resilience. I arrived in Louisiana 6 months ago, and I realized how people here are involved in environmental action. And you know that Louisiana is, due to its geographical situation and location, very vulnerable to climate change. And I got invited several times to Terrebonne Parish and to see all the work that's done with the levees there and the fight against the coastal erosion. So Louisiana is very involved, and that's a very good thing. And I think that's very important because at the local level, the fight against climate change is a good opportunity to develop, to have jobs, and for the economy it's very, very important. You know, to accomplish and to achieve an agreement in Paris needs some method. And it's not, you know, that France is the country of René Descartes, and we are very Cartesian, you know, reason. So on the road to Paris, the French Foreign Ministry is committed to respecting three main principles. First, we want to listen to each of our partners and to understand their concerns, to be able to take them into account when we negotiate the final agreement. We are not out for everything or nothing. We know that unlike with baseball caps, one size doesn't fit all with international negotiation, and our motto will be realism and pragmatism. No French arrogance, believe me. And this leads to the second principle. We want to promote the spirit of compromise and take into account national circumstances in order to reach a fair agreement. France will make a special effort to provide technical assistance to the most vulnerable countries in the implementation of their national contributions. Thirdly, we'll need a strong mobilization. This is the only way we will be able to seize this last chance to reach an agreement for COP21 before long. And this will require the involvement of each of you. Every stakeholder must be mobilized to help us, not only heads of states and diplomats like me, but also all of civil society, which means local authorities, NGOs, business community. And the message of COP21 should send to the latter should be, we are serious about low carbon economy. The technology is there or will be here very soon, so sooner and perhaps sooner than you think. Third point, perhaps very efficient one, there is money to make, so go for it. The next conference of the parties is based on 4 pillars. We have 4 goals. The first one is to reach an international agreement based on common objectives and to establish a legal framework for the post-2020 period in which each of the 196 parties So that's a hard negotiation, you know, when you have so many parties. We'll commit to taking action in order to keep the increase in temperature to less than 2 degrees Celsius. This goal was set in 2011 in Durban, and this is a rendezvous the world cannot miss. As Secretary General Ban Ki-moon said, there is no plan B because there is no planet B. The second objective is to gather the intended nationally determined contributions. Sorry, it's perhaps technical, but you're a lawyer, I guess, so you like that. Particularly in terms of emission reductions. These national contributions will tell us whether the path we are on is headed in the right direction. And I can only thank the US government for its leadership on this issue. The third objective is to set up a financial and technological package which will mobilize public funds and channel private investment for low-carbon transition and climate resilience projects. The goal is ambitious, but I think we can achieve that, is to reach $100 billion per year by 2020, and will specifically target vulnerable countries with this help. Finally, we'd like to urge non-state actors to take actions and commitments in order to contribute to what we call the Alliance for Climate. We need businesses, public and private investors, cities, region, and civil society to get involved. As a conclusion, I would say I'll talk about the next steps. There are still many challenges ahead, and we need everyone to step in, stay confident, and make the necessary efforts to tackle them. The next step will be to conduct informal negotiations before the end of the year on the following topics: differentiation, the legal nature of the agreement, and climate finance. Although we collected $10 billion between 2015 and 2018 for the Green Climate Fund, we are a long way from the yearly $100 billion we pledged to achieve by 2020 to develop a real low-carbon economy. There is a strong need now to unlock private investment for new technology, such as electric vehicles, energy storage, etc. And we need to integrate climate risk into investment decisions as well, to create incentives for the market and businesses. But again, yeah, I'm optimistic. Finally, the French government is committed to listening to all civil society groups. This will be absolutely critical to our success. In conclusion, let me quote the French writer Antoine de Saint-Exupéry. I'm sure you know Antoine de Saint-Exupéry, the author of Le Petit Prince, The Little Prince. We do not inherit the earth from our parents. We borrow it from our children. Nous n'héritons pas de la terre de nos parents, nous l'empruntons à nos enfants. So in that spirit, today, until and beyond the Paris conference in December, I urge each and every one of you to be on board and to help us to address the enormous challenges that our planet is facing. So thank you very much for your attention.
If you can hold your questions till the end, we'll make sure that there's time for questions and answers. But I'd like you to have the perspective of the other speakers, and then we can have a conversation.
Thank you.
Thank you so much.
Thank you very much.
Well, I take personal pleasure in being part of a panel in which René Descartes comes up. In fact, a René Descartes joke. René Descartes walks into a bar, and the bartender says, "Monsieur Descartes, the usual?" He says, "I think not," and disappears. I didn't say it was a good joke.
Never say no to a joke.
That's right. Well, I don't get to use that one often. Perhaps to the good. Our next speaker will be Dr. Tor Tornqvist, Tulane's own scientist of the world. Tor will explain a little bit about what the arc of climate science is, And of course, if you read the newspapers, you're led to believe that there's this vast disagreement on what we know, what we don't know. And Tor can put some of that in perspective. I can tell you from working with Tor and his colleagues, where there's disagreement, it is on degree, not direction. Not on the fact of, but the extent of, and how much time we have. Critical issues, if we're going to be serious in what we plan and what we do. Tor, the floor is yours.
Thanks so much. It's a real pleasure to be here. I have two screens, so I had a laser pointer, but that only works on one screen, so maybe I'll try to use, see if I can use this. Yeah. So, obviously, when I got this invitation to speak here, I thought about it a little bit, and climate science is, of course, a very, very large topic. So, I obviously will be very selective. What I will do, as you can see, looking at the title, I will spend a fair amount of this presentation talking about where we are here in Louisiana within the context of global climate change. Gregor has already pointed out that we are in a very vulnerable location, and I'm sure you're all very aware of that. But I want to start off with a little bit of wider context, and I'm actually going to do something I haven't done before, but to talk a little bit about climate change from a historical context, how climate science has actually evolved. Before I do that, I want to put up a graph or a diagram, and for those of you who don't dig science, don't worry, I'm not going to do too many of these, and I certainly won't go through this in any detail, but I just want to point out a few key elements of the Earth's climate system that basically feed into everything else that we'll talk about. So what you see here is basically the radiation budget of the Earth's atmosphere, where, of course, everything is driven by solar radiation that is coming in here, and then a lot of complicated things start happening. And there's just two I want to draw your attention to, and that is because they're particularly important within the context of climate change caused by human actions. The first one is that solar radiation that is coming in and that eventually hits the Earth's surface, the land surface, or the ocean surface for that matter, a portion of that will be reflected straight back into the atmosphere. And it may look like a relatively small part, but this is actually very important. The areas where that happens are areas with white surfaces. And as you can imagine, those areas are near the poles. And you may have heard about the fact that most of the warming that is happening today actually happens at these high latitudes. And that has a lot to do with what's going on here, because if you melt these snow-covered surfaces, then less of that radiation is going to be reflected back into space, and more heat will be absorbed by the Earth, whether it's in the ocean or in the atmosphere. And this is important because we'll talk later about ice sheets, and that, of course, has everything to do with this issue. And then we have, of course, the other side here, on the right-hand side of the slide, are greenhouse gases. And the greenhouse gases are like the insulation in a sleeping bag, if you will, right? So the Earth emits radiation itself, just like you would if you were lying in a sleeping bag. And if you have a really high-quality sleeping bag with good quality insulation, most of that heat will be trapped, right? And that's why we have a nice climate we can actually live in. Without greenhouse gases, there would be no life on Earth. So they're critical. But, of course, if we suddenly start to increase the amount of greenhouse gases in the atmosphere, something is going to happen, and we're going to trap more heat. And I think it's important to recognize that this is very, very old science. this has been known for a long time. And I'm just going to summarize this with these three individuals who have played key roles, and to appeal to the French pride, we'll start with Joseph Fourier, who was a mathematician and physicist. For those of you who are into math, you've probably heard the name Fourier because there is something called Fourier analysis, but that has nothing to do with what we're talking about here. Fourier was the first one to demonstrate theoretically that a number of gases, such as CO2, had the ability to trap that radiation that's coming out of the Earth. So he basically argued theoretically that something like a greenhouse effect had to exist. Then a few decades later, a British physicist called John Tyndall, he actually did the experiments that were necessary to prove that this was indeed true. Okay, so that was in the mid-1800s. And then towards the end of the 19th century, a Swedish chemist called Arrhenius, and this was kind of a side hobby for him because he was primarily known as a basic chemist, but he actually was the first to make the case that the burning of fossil fuels, which of course had already started, by that time, would likely lead to a changing climate in the future, right? So the bottom line is, and Arrhenius actually went on to predict how much temperature change might happen because of that. And the interesting thing is that his estimates were actually not so far off from the estimates we use today. Now, obviously, he knew a lot less than we do today. And the one thing he certainly didn't do, and he wasn't able to do, was to actually demonstrate that it was happening because, in the late 19th century, we had just gotten started with burning fossil fuels, and the greenhouse gas concentrations in the atmosphere had only changed by a small amount. So it was way too early to actually see the effect, right? But the bottom line here is that by the end of the 1800s, the big picture had already been figured out, right? So if you run into a climate change denier, which you can find on every street corner in Louisiana, just tell them this. We've known this for a very long time. All right. This is a record of CO2 measurements. This is actually an older graph. You can see if you look at the years, but it doesn't really matter. It's a rising trend. The measurements started back in the 1950s. Actually, Gregor referred to the fact that we broke a record just 1 or 2 years ago when we hit 400 parts per million, which is obviously significantly higher than what you see here. But then, of course, the question is, how does this fit in the larger picture, in a longer context? Because we know that CO2 has changed in the atmosphere due to natural causes. And the best way to do that is to look at measurements of CO2 concentrations in the atmosphere from ice cores. And the best ice cores come from Antarctica. And this is an example of a record that goes back about 400,000 years. And what you can see here is that there were actually large variations that were obviously natural because this is long before any human impacts. These were actually ice ages, fluctuations between ice ages and the warmer periods in between. What you see here in this red line here, which is basically a vertical line, is this same record, but now compressed, right, to fit into this time scale. And for those of you who have seen Al Gore's movie, you may recall that at some point he shows a similar data set, and he has to get on this little elevator to actually reach he wants to point to this rise that has happened in the last century or so, and that's really the only way he can do it because it's way out of range from anything we've seen before. We actually know now that you have to go back about 3 million years to find CO2 concentrations that were similar to what we're seeing today. So we haven't seen that in a very long time. And the other really important thing is the rate at which CO2 concentrations are changing right now is unprecedented, right? So that kind of brings us to something that will play a big role later this year in Paris, because obviously these policies we're hoping to see happen, they will have to be guided by underlying science. And that science is provided by something called the Intergovernmental Panel on Climate Change that produces a set of reports that summarize the current state of not just climate science, but also climate impacts and policy ideas. As it happens, the most recent set of reports just came out, say, within the last year or so. And what you see here is the first volume out of 3. So this is basically the basic climate science part. These reports have... this is actually the 5th iteration. The first set of reports came out in 1990. And they're growing steadily because the amount of research, the amount of activity is just increasing very, very fast because it's a high priority issue. This last set of reports, if you add them all together, it's almost 5,000 pages. So if you want to have a good read, that's what you want to look at. So I'm just going to show you a few of the outcomes from this most recent analysis. And of course, the most basic one is global surface air temperature, as derived from direct measurements with thermometers. Okay, and we have those going back to about 1850. So you see here the record that goes all the way to the year 2012. The upper panel shows annual data, and obviously you have annual variability, right? That's what climate does. So a better way to look at it is to actually average the data into decadal values, because then you can actually more easily see the actual trend. And what we see here is that earlier on there wasn't that much going on, but towards the end of this century the increase in temperature has really started to pick up. So not surprisingly, it's also during this time, I would say somewhere halfway during this time period, that the scientific community became really convinced, like, it's clearly happening. There is no other way we can explain this than this being primarily driven by greenhouse gas increases in the atmosphere. There are simply no other mechanisms that can explain this. When people talk about natural variability, well, we all know that natural variability exists, but there are no known causes that can explain what we're seeing here without taking into account greenhouse gas increases in the atmosphere. All right, so here in Louisiana, or in the United States for that matter, this warming will have all kinds of impacts, but the one, especially in low-lying coastal areas like we have here, we're mainly worried about the big ice sheets. And the one that matters most to the United States is Antarctica. So what's going on in Antarctica? Well, there are some things of concern. This is actually a set of satellite images that was shot in 2002. And what you see here, this is actually something that happened within a matter of just a few weeks, or maybe even days, going from here to here to here to here. And what you see here is an ice shelf. It's basically a thick layer of ice on the shallow ocean that kind of supports the land-based ice that is sitting behind it. This is on the Antarctic Peninsula right here, and within a very, very short period of time, that whole thing just fell apart. Okay, and this is a very, very large area. We're talking about, something like the size of Rhode Island that just bang falls into the ocean almost instantaneously. These things have started to pick up. There is actually a possibility that this is something that was recognized only within the last few months. There may be another event like this that is becoming inevitable in Antarctica over the next couple of years. And so things are changing there very fast. We see similar things in Greenland, which is, of course, the other big ice sheet. And that is bad news for anyone in any low-lying coastal area around the world. So let's talk a little bit about ice sheets. Our understanding of ice sheets can benefit a lot from going back in time. I mentioned earlier that we've had ice ages. The most recent one peaked around 20,000 years ago. And this is a map of the Earth. It's kind of an unusual projection, but it's a good one if you want to visualize ice sheets. So what you see here with this darker shading are the two remaining big ice sheets, Antarctica and Greenland. And then in addition, we see all these large white areas which were ice sheets that existed back during the last glacial maximum. The biggest one was the one that covered most of Canada and the northern parts of the United States. So what kind of conditions actually led to this? Well, we now know that global mean temperature was probably somewhere near 4 degrees Celsius lower than it is today. Now just think about that. That's not very much, right? So that seems like a relatively small amount to make that much change. Now we just heard that we're trying to limit future warming to something like less than 2 degrees Celsius, which is going to be very, very difficult to accomplish. And in fact, if we don't do anything, we could potentially see 4 degrees Celsius of warming, within the next century. Keep in mind that building these huge ice sheets will drop sea level globally with an average amount of about 400 feet. Okay? So these are huge changes. So only looking at this, we can see that, raising global temperatures by a couple of degrees is a very, very dangerous experiment. Now, of course, the one thing you can say is well, it took a long time for all that ice to melt. Yeah, it didn't happen over a century or so. But these changes can set in motion sea level changes that we simply cannot reverse. So just to show you the best reconstruction we have right now, and this is a publication that came out last fall, this is global sea level change in the last 35,000 years. So here we have our last glacial maximum, right? And then we get this huge rise. And there were periods within this rise where, really dramatic things happened. There is around 14,000 years ago, right here, there is a rise on the order of 10 to 20 meters that happened within probably about 300 years. So those are things that can potentially happen with ice sheets. And I will get back to that at the end of the presentation. This is an inset that shows a detail of the most recent part of the global sea level record. And one thing you can see is around 7,000 years ago, there is a pretty sudden reduction in the rate of sea level rise. After that, we're only talking about a couple of meters. That is actually the time when that North American ice sheet was gone, right? And that was, of course, the largest contributor to, a lot of what we see here. So that's the reason why, in the last 7,000 years, the rate of sea level rise has been slower. So let's now zoom in and look at just the last few hundred years. And what we see then is that, until the late 1800s, sea level was relatively stable, with some minor fluctuations. And then it started to increase. And if you look really carefully, you can see at the very end of this record, you see this little blue line, light blue line, which is actually a little steeper than anything you see before, earlier in the record. That light blue line is very important because that's the satellite era where we have the best available observations of changes in the sea surface. So if you look at the slope of this line, we find that the rate of sea level rise globally average today is about 3 millimeters per year. Okay, it doesn't sound like very much, but I'll show in a moment that it is actually very significant. And you can obviously see that it's a very, very distinct departure from what happened prior to that. So if we then go to Louisiana, I'm sure many of you have seen this map before. This is our land loss map where everything that is shown in red is basically land that has already been lost. There is, of course, more land that we expect to be lost in the future. And there is a whole host of different reasons for this. But accelerated sea level rise is one of them. And going forward into the future, it is very likely that that's going to become an increasingly important cause of future land loss, not just in Louisiana, but in many other low-lying areas near coasts around the world. So let's look a little bit at some local research within my own group. What you see here is a couple of graphs, and I'll start off with the bottom ones. These are tide gauge records that measure directly sea level change on the coast. The best known in the Gulf of Mexico is Pensacola, Florida, which starts in the 1920s and shows a distinct rising trend. We have places like Grand Isle, which show a very, very rapid rate of sea level rise because the land there is subsiding very fast. So what's important here is to put this in context of what happened prior to any human activities. So this is work by one of my former students who is collecting some of his samples right here. This is a record of sea level rise from here in Louisiana that is a 1,000-year record from about the year 600 to 1600, right? So this is all prior to the Industrial Revolution. And what's important here is to look at the rate of sea level rise, which was about 0.5 millimeter per year. So yes, there was sea level rise, but it was really slow. And if we compare that with what we see during the last century, we see that acceleration that we saw worldwide on my previous slide, we see that here as well, right? You can see that the rate of sea level rise has gone up by about a factor of 4. So if we then look at it in an even longer geological context, this is actually a sea level curve for coastal Louisiana going back to about 8,000 years ago. And what we see here is something that looks very much like that global record I showed earlier, that we have higher rates between 8 and 7,000 years ago, and then there is a pretty distinct reduction in the rate of rise, which again is because that big ice sheet in North America was gone, so there was less ice melt that contributed to sea level rise. And you see here those rates, we dropped from about 3.5 millimeters per year to about 1.5 millimeters per year. So what we can conclude from this is that the rate of sea level rise that we see today here on the Gulf Coast is higher than anything we've seen in the last 7,000 years. And keep in mind, the Mississippi Delta that we live on formed within the last 7,000 years. And the reason it formed was that the rate of sea level rise wasn't too high. So those facts alone show that we are in very dangerous territory. So let's go back to this graph that we just looked at, and let's take a look at the most recent predictions by the IPCC for the next century. Well, when the IPCC makes predictions, they have to use different scenarios of greenhouse gas emissions, right? What we're going to do, what's going to happen in the future, depends in the first place on the kind of action we take or don't take. So if we take significant action, if the talks in Paris are successful, we may actually be able to follow this blue line. And what you see here is, even if we are successful, we're still going to have sea level rise. That is going to be irreversible, right? Sea level rise is going to continue for centuries. However, it will be relatively manageable. If we let things just go the way they go right now, and we keep blasting more greenhouse gases into the atmosphere, we are more likely to follow something like the red line. And that's bad enough for this century we're in right now. If we look beyond this century, it's going to be even much, much worse. And so I'm going to finish with a set of graphs, and I have to tell you, this is not a set of good news graphs. This is actually really frightening, what we're going to look at. But, we have to face reality. This is a study that came out also within the last few years that actually looked at sea level rise in a slightly different way and did not look at it as in the previous graph as how are things going to change as a function of time, right? So what are things going to be like in the year 2100 or maybe beyond? But you can see here on this axis that it's plotted as a function of temperature, right? So the idea here is that if we warm the Earth by an X amount, how much sea level rise can we expect from that? So the one thing this graph, this set of graphs doesn't tell you is when this will happen. It just tells you this is likely to happen eventually. It may in some cases take a long time, but it is something that may be irreversible. There is a lot of stuff going on here, and I'm going to draw your attention to this green plot here in the middle. You can see here, this is sea level in meters, and you can see these are smaller numbers, so we're not going to worry too much about them. Here we're looking at much larger numbers. So this panel here in the middle is the Greenland ice sheet. And the Greenland ice sheet is known to behave in what we call a nonlinear way. And that means if you raise temperature gradually, it's not just going to start melting more rapidly, but it may respond in a very nonlinear way, that it may suddenly cross a tipping point and may start melting very, very fast. And then, of course, the important issue becomes, where is that tipping point? And you can see it's right here, right, where you suddenly start ramping up from maybe less than 1 meter of sea level rise to as much as 6, which means you've melted most of Greenland. And if you look right here, you can see that happens somewhere maybe between 1.5 and 2 degrees Celsius of warming. So what it means is that goal of trying to stay below 2 degrees Celsius of warming is very ambitious, but it may not be a bit ambitious enough. So again, the one thing this graph does not tell you is how long this will take to play out. I mean, it's totally conceivable that it might take a few thousand years to totally play out. But the bottom line is, once we hit this point, there is no way back, right? We may have a lot of time to try to adapt, but there is no way back. So let me just finish with a few take-home messages. So remember, from the beginning of our presentation, anthropogenic climate change is very old science, okay? As we all know, Louisiana is among the most vulnerable states in the nation, and for that matter in the world, due to climate change, particularly due to sea level rise. And ultimately, ice sheets are, you could argue, are the world's largest threat for the future. And as we saw, even with relatively modest warming, we cannot be entirely certain that we are not going to cross a tipping point. So I'll leave it here.
That's a lot to take in. But there are two things that we've already heard in the presentations that I think really set us up for Will Burns. One is that these things are already starting to happen. In fact, coastal restoration plans, things like that here and elsewhere, are in fact aspects of beginning to acknowledge and adapt. And also, as Gregor noted, that there is opportunity. There's money to be made once you finally figure out that adaptation management makes sense. We tend not to spend much time planning for those things that we have no plans for, that we have no capacity to understand and change. Clearly, we're now getting to a point where our understanding and our understanding of what is at stake have the potential for changing the level and nature of this conversation about climate management. That really takes us into the area that Will Burns has done extensive work in. Because, quite frankly, once we begin to understand that this is part of our life, it will be part of our economies, part of our communities, and quite frankly, then the civics, if you will, can change with this. There will be a constituency for knowledge, and knowledge that can lead to action. Maybe. We'll see what Will says. Will?
Okay, we started late, so I am going to try to motor through this so that we have enough time for questions. Oh, great, thank you. Okay, so in the current policymaking milieu, there's two primary responses that we can formulate in terms of climate change. The first of these is obviously mitigation, which is defined by the IPCC as human interventions to seek to reduce the amount of greenhouse gases that we're putting into the atmosphere, or to enhance the sinks, things that can store carbon dioxide, such as soils and trees. The other primary response to climate change is what I'm going to focus on, which is adaptation, which is defined as adjustments in natural human systems in response to climatic stimuli. And in terms of anthropogenic or human responses, there's a wide range of things that we can do, right, to adapt to climate change. We can build seawalls, for example, to try to withstand the rising levels of the world's oceans that we've heard about before. We can also seek to reduce the loss of water in our systems to withstand the anticipated decreases in water supplies that will exist in many parts of the world. Or we can seek to develop drought-tolerant crops to respond to reductions in agricultural production that are anticipated, especially in some of the areas that already are severely vulnerable in terms of food, such as sub-Saharan Africa and the projections of temperatures in the increase. Now, at one point, many people resisted any focus on climate adaptation as a policy response. And the argument was essentially one that we call moral hazard. The argument is that if we focus on our ability to adapt to climate change, then we'll take our eye off of the need to severely reduce our greenhouse gas emissions in the future. We've now reached an inflection point where we no longer embrace that quaint notion, and that's basically for two reasons. First of all, the simple fact is we ain't reducing our greenhouse gas emissions, right? And we need to live with that fact. Between 2000 and 2007, the Intergovernmental Panel on Climate Change's worst-case scenario in terms of greenhouse gas emissions were actually outstripped by what actually happened in the real world. Greenhouse gas emissions were rising at about 3% a year. And even though that slowed down a bit, especially because of the recession that occurred in the first part of this decade, they continue to increase substantially. We now are looking at a greenhouse gas budget of about 535 megatons of additional gigatons of greenhouse gas emissions that we can emit into the atmosphere before we pass this 2 degrees Celsius threshold that the two previous speakers have talked about. How long will it take us to blow through that budget? Current estimates are only about 16 years. That means that by the time we get to 2030, it is conceivable that we will pass the 2 degrees Celsius threshold. And it's likely that we'll substantially blow past that threshold because we're not going to stop emitting greenhouse gas emissions, especially in terms of rapidly growing, large developing countries such as China, Brazil, and India. And indeed, recent estimates by the Intergovernmental Panel on Climate Change, the International Energy Agency, etc., conclude that we're likely to see temperature increases in this century alone of 3 to 3.9 degrees Celsius or more. Okay, which means that we will have potentially catastrophic implications for both ecosystems and human institutions that billions of people rely upon. So the need to adapt is critical, and we can no longer say, let's not focus on that. The second reason is something that the two previous speakers have alluded to, which is the inertia of the system. A lot of the greenhouse gases that we put in the atmosphere remain in the atmosphere for hundreds of years. So they're the gift that keeps on giving, which means that once we put these greenhouse gas emissions into the atmosphere, we've baked in a certain amount of increased temperatures in the future. The reality is we've already increased temperatures by about 0.8 degrees Celsius, okay, from pre-industrial levels. And even if we now turned off all the lights in here and all the computers and crawled into caves today, Okay? We now have another 0.7 degrees Celsius increase in temperatures baked into the system over the course of the next 20 or 30 years, and in the course of the next 50 years, probably about 1.5 degrees Celsius. So the point is that no matter what we do now, we're going to have to adapt to climate change, even if we massively reduce our greenhouse gas emissions starting tomorrow. The other reality, though, is that what we do in the shorter term, and this is an example from my state of California, what we do in the short term in terms of mitigation doesn't make that much difference, which means that adaptation is critical over the course of the next 20 to 50 years. But in the longer term, what we do in mitigation becomes critical, because the reality is that even if we think that we can adapt to climate change, even in highly developed countries, eventually greenhouse gas emissions and temperature increases that are projected over the course of the next century will eventually overwhelm virtually any possible effective kind of adaptation response. So what we need is a combination of adaptation and mitigation to potentially address climate change in a way that does not result in severe responses in the longer term. So the question is, and I want to look at this very briefly, is what are we doing in terms of legal responses to climate change at the international level, and what might happen at the COP21 in terms of the long-term agreement. So I want to very briefly look at the Framework Convention on Climate Change, our primary international treaty to address this issue. It has several provisions on adaptation. I'll just look at a couple of them. First of all, Article 4 mandates that the parties cooperate in preparing for adaptation to the impacts of climate change, and talks about developing coastal responses, water responses, agriculture. It's essentially a laundry list of what the scientists tell us need to be done, and virtually nothing else. Article 4.4 also talks about assisting developing countries that are particularly vulnerable to climate change. And again, this is mom and apple pie sort of stuff, right? We know we need to adapt, and we know we need to help people that are vulnerable. Okay? Noticeably absent, of course, in this agreement are a couple of critical things. One, any targets for when we begin adaptation and timetables. Second of all, perhaps most importantly, any calculations of the amount of money that will be necessary to do this, especially to assist the most vulnerable. And third of all, most critical, no dedicated funding source that ensures that this will happen. Right? And this in many ways was the problem with the Framework Convention in general, right? But everybody said it was just a framework. So of course we're going to move on to more specific sort of responses when we get to the Kyoto Protocol. So let's look at what the Kyoto Protocol provided for in terms of adaptation, okay? We look at Article 10. It talks about developing regional programs and national programs to facilitate adequate adaptation to climate change, right? And it, again, looks at some of the sectors that are most likely to be vulnerable in terms of climate change responses. And it also talks about providing financial resources, including for the transfer of technology. But again, noticeably absent is any specific amount of money that is mandated to be provided for these responses and any specific funding source. Okay? So in acknowledgement of this, the parties to both the Framework Convention and Kyoto started to develop funding sources for adaptation. And these were three of them that were developed early on in this process. The first of these was developed in 2001, called the Special Climate Change Fund. And again, it provides for adaptation needs in the context of several sectors, including agriculture and water resources and coastal management. Also, at the 7th Conference of the Parties, we established the Least Developed Countries Program, which, again, talks about developing funding for adaptation measures for the most particularly vulnerable countries that exist. And then also under the Kyoto Protocol, we established the Adaptation Fund. Okay? And the Adaptation Fund was notable because, unlike the other two that were voluntary and just relied on the kindness of strangers, this was a funding source that actually, this was a funding mechanism that actually had a funding source. And as you can see, 2 2% of the carbon credits that are developed under the Clean Development Mechanism. This is a free market mechanism to address climate change. 2% of the proceeds from that were to be provided for in terms of this fund. Okay. There's also, during this time, were discussions to develop institutional responses to climate change. There was an acknowledgement that the provisions within the Framework Convention and Kyoto were vague. There was very little coordination, very little focus at this point. And so ultimately the parties decided to establish an adaptation committee in Cancun. Okay? In addition to that, perhaps most importantly, they decided to start developing mechanisms to provide the kind of funding, at least in theory, that are necessary to meaningfully address climate change. And you can see this in the Cancun meeting, where it talks about a significant share of multilateral funding to be flow through this new Green Climate Fund that's been established. And the purpose of the Green Climate Fund is to provide developing countries with funding for both mitigation responses, efforts to reduce greenhouse gas emissions, as well as adaptation to climate change. And it was roughly agreed that about 50% of these funds should be provided for adaptation and about 50% for mitigation. Okay, so the question is, what are the challenges heading into COP1 in terms of adaptation? What are the issues that the parties need to be most focused on? And then lastly, I'll very briefly talk about how they might respond to it. Well, one major issue, as you can imagine from my remarks already, is money. Okay, and the sober fact is that we need a tremendous amount of money in terms of developing countries to adapt to climate change of 2 degrees Celsius or more. One recent study indicated that global adaptation costs are estimated to be about 7 to 10% of the overall damages that we're estimating will occur in terms of climate change. And many estimates of those damages are in the magnitude of trillions of dollars. Okay? A number of studies have estimated that by the year 2030, the developing countries will need somewhere between 28 and 67 billion dollars, billion with a B, annually in terms of outlays from developed countries to be able to effectively adapt to climate change. And this number may be far too low. The United Nations Environment Program, in a study published 2 months ago, estimated that these estimates were wrong by a magnitude of 3. And so it may be that we need somewhere in the order of $100 billion to as much as $180 billion annually in outlays for developing countries to adapt to climate change. Unfortunately, we have a massive disconnect between that kind of imposing number and the amount that we're providing. Okay, this is an estimate of how much was being provided by the 3 mechanisms that existed at one point within the Framework Convention and the Kyoto Protocol. Overall, if you looked at this, the estimates were we had approximately $300 million, million with an M, to deal with adaptation issues. That's obviously a little different than $100 billion. The good news is, as I indicated, in Copenhagen and Cancun, we began to discuss long-range needs that were more realistic in terms of adaptation. As Gregor had indicated, we now have $10 billion in the Green Climate Fund to address adaptation. There are commitments, albeit vague at this point, for $100 billion by the year 2020 to be roughly divided between adaptation and mitigation. Okay, so that's one major challenge that lies ahead, though, and it's the 1 million pound elephant in the room. How do we scale up to $100 billion annually in terms of funding? As Gregor indicated, many developed countries face severe fiscal constraints internally, and so they're now being asked to provide $100 billion to other countries. And the question is, where will that money come from? And this has been a real struggle. Some developing countries within the Framework Convention have argued that a dedicated funding mechanism should be established based on a formula, either based on the percentage of greenhouse gas emissions, for example, of each developed country, or gross national product, or some other measurement that would provide a quantitative measurement of the amount of commitment that countries should provide, and essentially provide a guaranteed source of funding for adaptation. The Obama administration, in response to that, said there's a diverse number of responses that could occur in terms of adaptation. In other words, that means we're not going to do that. Okay? So the question is there another way to get that? There's lots of discussions of potential dedicated funding mechanisms. For example, if one were to put a $7 per airplane ticket assessment on everybody that flew in the world, this could yield $14 billion annually. If we were to provide a tax on aviation and shipping by auctioning greenhouse gas allowances from these mechanisms, it's estimated we could provide another $22 billion. A Tobin tax, a tax on currency transactions, it's been estimated could yield somewhere between $30 to $35 billion, even if it was set at a level of 0.02% annually. So there are potential funding sources, but the question is, will we commit to those, especially when that money would be largely flowing from the north to the south? And that's one of the challenges. Two of the other challenges that exist is, first of all, avoiding maladaptation. Not every adaptation response is good. If you build seawalls in areas, for example, in some areas you can accelerate coastal erosion. We've made lots of mistakes already in terms of adaptation. We have to figure out how to develop a knowledge base that allows us to effectively adapt in the future if we're going to spend the money that we have wisely. The other problem that we have, and perhaps the greatest problem, is that the models that we use for climate projections are extremely granular at the regional level. The models that Tornquist talked about that project temperature increases at the global level, precipitation increases, sea level rises, are pretty good in terms of the agreement between those models and what we've seen historically. But when you move down to the regional level, those models are a lot less effective. Take one example. I work a lot in a South Pacific island called Tuvalu. Okay? And Tuvalu has had some models done of precipitation increases by the year 2050, or precipitation decreases. And one model that was presented to Tuvalu estimated that precipitation would increase 32% by the year 2050 as a consequence of climate change. Another model indicated that precipitation would decrease by 20%. Okay? How do you, in the face of that, develop effective adaptation responses? If you're a country with extremely limited resources, do you now put lots of money in drought-tolerant crops, etc., knowing that that money may be quote-unquote wasted if the responses are different, if you should have been responding to increased levels of precipitation? How do you develop systems that are resilient? That's an extremely challenging thing to do. And so, moving into Paris, there's various responses that may occur. One is to develop methodologies that mandate specific amounts of money be provided to developed countries based on formulas, okay, utilizing some of the principles that we talked about before, gross national product, greenhouse gas emissions. Another potential response, one of the brackets, and there's 1,500 brackets in this document that exists now as the negotiating document. One of these brackets simply provides that we should enhance the amount of funding that we provide to countries, which may put us back in the situation we were in the Framework Convention, where there's very few assurances of what will happen in the longer term. Another issue is monitoring of the funds that are provided. Some people want accountability of governance in developing countries. Many developing countries are extremely resentful of that. They argue that any money that developed countries provide to developing countries in terms of adaptation is not aid, but reparations for what's being visited upon them in terms of climate change. That obviously creates huge frictions between developed countries and developing countries in terms of how we respond. And then lastly, we have to develop these knowledge bases, which are going to cost money, of what adaptation responses work, what don't, which don't. We have to diffuse that throughout the world so countries can learn from each other, and we have to be able to adapt in a world with high levels of scientific uncertainty, both now and in the future. And so adapt we must. The question is how we will adapt and whether the resources we have will be adequate. And that's one of the imposing challenges that we have moving into COP21. Thank you very much.
Well, that was terrific. I'm all ready to adapt. We don't have much time for questions, but I want to make sure we start the process. And also, I would hope you would use the breaks and the rest of the program day, to take advantage of, seeking out our speakers, not just on this panel, but others, so the conversation can continue. And I think I see a question from Mr. Harold Scheffler.
Yeah, if 40% of the world's population doesn't have electricity, and in terms of global warming, do we keep them in the dark, or do we find ways to electrify them without contributing to a negative in global warming?
Which of my panel would like to address that? If you want to step back up here so he can stand. Yeah, that's good.
Those kind of equity questions are huge, right? It's very easy for us in the developed world to now say, we've got 60-inch flat-screen televisions, and now we've got to respond to climate change, so you've got to sacrifice, right? It's neither fair nor politically viable, right? So we have to try to address this issue that's called energy poverty, right? And some of the potential responses are to try to develop low-impact sort of microgrids that utilize renewable energy, for example, substantial increases in energy efficiency in some of the large urban areas in these kind of countries to be able to facilitate more of a transfer of those electricity to these other areas. But it's a huge question, and it's going to, on a parallel track, take huge amounts of additional financial resources. And the question is, where are those financial resources going to come from? And nobody's got a really good answer, in my opinion.
And I would observe also that maintaining people in poverty as part of a mitigation strategy is morally suspect. But also that we will probably see energy follow more of a communications pattern, where the communications grid that was created for what we would call the first world is nothing like the communications networks that are being created in the emerging world. And so I think as long as our business models for international development aid and things like that don't get in the way of some of that innovation, the past is not necessarily prelude. Any other questions? Yes, Bob.
Talking about a government-focused conference leads to more discussion about top-down regulatory approaches. I want to ask you about charging more for consumption of fossil fuels, which not only puts the incentive for all the consumers in better alignment with our goal, but also generates the funds that you were referring to for adaptation, etc. Can you talk a little bit about that aspect which we haven't emphasized today?
I mean, it's a fundamental tenet that you've got to capture the externalities, right, associated with climate change, and it should be costed into our products so that we respond efficiently, right? That's free market economics. But there's a real breakdown between a lot of these full-throated supporters of free market economics and any discussion of actually doing that, right? And so there's been discussions in this country of trying to do that in two possible ways. One would be a carbon tax, right, that would be imposed based on per ton of carbon dioxide that was emitted. And that funding could be used in a couple of ways, and you're talking about potentially hundreds of billions of dollars, right, if you set that tax at a level that's going to be effective to reduce emissions and to incentivize technological breakthroughs. You could either make it revenue neutral. In other words, you could give all of that money back but still send the price signal and the incentives to reduce emissions, or you could take a percentage of that and funnel it into research and development for technological breakthroughs that hopefully reduce the costs of decarbonizing the economy in the future. those proposals have gone nowhere. There was a ripple a couple years ago, a discussion that some prominent Republicans, such as George Shultz, used to be in the Nixon and the Reagan White House, were amenable to that, but it went nowhere in Congress. The other possible way to do this really is cap and trade, right, which also puts a price on carbon by setting a cap and selling allowances. That we had a bill that passed the House a few years ago and then died in the Senate. In the current Senate and House, there's not a snowball's chance in hell of that being viable. And so it's very difficult to figure out where we get to a point where we put a meaningful price on carbon, given the political resistance.
Yeah, because that's the U.S. situation, and I'm sort of asking about the world situation, whether the rest of the world might lead the U.S. in the right direction, because we're got more intelligent leadership elsewhere.
Well, we've got the European, not necessarily in my opinion, no offense, but we have the European Union emissions trading system, which is a cap and trade system in Europe. But allowances right now are somewhere at about $5 or $6 per ton of carbon, right? In order to meaningfully facilitate fuel switching, to incentivize people switching from coal and oil to natural gas or renewables, you probably need a carbon price of somewhere around $30 to $40 per ton. So it's nowhere near where it needs to be. Same in terms of technological breakthrough. The political reality is that countries in Europe haven't been able to set a cap that's sufficiently stringent to create the kind of prices that facilitate that kind of shift. And Europe is clearly the leader in this context. So it's hard to be sanguine that anybody else in the world is going to lead in a way that's effective. And the cap and trade program that we have under Kyoto suffers from the same maladies. We're selling allowances right now somewhere around $1 a ton, right? It's simply way too, we set the cap way too high, and the reason we set it too high is because of the political realities. People aren't willing to pay the prices that are necessary to facilitate this transition.
If I could do a follow-up, because I want to ask Gregor a follow-up on that, because obviously we're talking about what's the legal architecture going to be for setting these things, and where will the impetus for that come from? And I was wondering at COP21 whether we're going to be seeing a greater role for external actors like the insurance markets, folks who are going to be putting, when private capital is exposed to risk, the world of possibility tends to change. At COP21, do we see a greater role for investment capital, insurance, and others to play a role in urging a different approach?
Regarding the legal framework, the idea is to have a core of contraignant, a constraint, on a legal point of view, a core of an obligation, I would say, for everybody, and a lot, some more soft and other agreements, in any directions. So that's going to be negotiated in Paris, and it's already negotiated now. It's been talked in Geneva, for instance, mid-February. The negotiation framework has been agreed. The goal was to have a 30 pages document. It was 90 finally, 90 pages. So I think now the time is to gather all the possibilities and to exclude no one, perhaps to reach an agreement in December. That's the goal, and that's the role of the presidency. So yes, of course.
Well, we are now actually a bit beyond our time. We do have a break. Please get some cookies, coffee, other things, continue the conversation, and enjoy your summit. And thank our panel, please.